I'm Dan Woods. I work at Netflix right now. I work on the engineering tools team with Justin and Rob, if you guys saw their talks yesterday. I work in the delivery engineering subsection of that group, which is specifically for tools like Asgard, open source tools like Asgard, where we do continuous delivery, continuous deployment type stuff. You can reach me at Gmail. Please feel free to email me directly with any questions that you might have or comments or feedback or anything along those lines. I'm also an editor with InfoQ, where I write articles and cover news items in the JVM and Java space. We're always looking for writers, so if you guys are interested in JVM technologies, then please feel free to send me an email. I'll get you in touch with the right people. I'm on Twitter at DanVeloper. If you don't follow me now, you definitely should. Like I'm a super interesting guy, and my tweets are totally relevant. So please follow me. You can find me on GitHub. All the code from this example and my other presentations and open source projects that I do are on GitHub/DanVeloper. I'm also a Red Hat certified engineer. It doesn't mean much these days, but it used to. So we're here to talk about the provisioning plugin. And what exactly is the provisioning plugin? So the provisioning plugin is basically a plugin for Gradle that enables the automation of provisioning server infrastructure through the generation of common installation media, right? So that's kind of a long way of getting at. We create an ISO. The plugin creates an ISO for you that you can go off and deploy, and it's something that's reproducible. It allows you to bring up a server in a state that you've pre-configured and that you know about. So I first introduced this idea of a provisioning plugin for Gradle last year when I was doing a talk that was entitled Groovy for System Administrators, that basically was a talk about how we can leverage the Groovy ecosystem for doing system administrative related tasks and activities and for automating that kind of stuff. And I'm not just talking about like pulling a folder or doing LSs or checking that a file's there. I'm talking about like real low level kernel stuff. That was at the Groovy Grails Exchange last year. So if you guys are into DevOps type stuff, I'd recommend checking that out. It's pretty interesting. But I think pretty interesting, right? I'm not opinionated on my own stuff, but I think that it's a really pushing the boundaries of what Gradle as a tool was maybe originally designed to do, and I think that that's such a great thing. The structure that Gradle provides and the ability to do a lot of stuff like this is one of its greatest powers, and it's such a great selling point. And this is certainly I think a great use case for Gradle. So basically, after this long-winded description of what the provisioning plugin is, I guess it gets down to the real question of what are we trying to do with this thing, right? And why is it in Gradle at all if we're not talking about building software? So effectively that brings us to this point, which is what we're doing is we're building servers, right? So when we build software, they need to run somewhere, and we'll get more to why we would want to build a server specifically, but effectively we need a way to provision a server into a known state and get our software onto it. And there's a lot of ways of going about that. This is just one of them. But I happen to think that this is the right one, and I would encourage you to believe me. So we'll talk about some of the features and some of the specifics of it. So the features of the plugin are that it provides a nice DSL within your build script for determining what a server should look like and all of its configuration and attributes, and also talks about destination type stuff, like where your server should run, even though that's optional. Like I said before, it enables the provisioning of server infrastructure, and in doing that, it creates a installation ISO. So this plugin, basically using it within a build script, allows that ISO, that image, to be archived off somewhere and is able to be reused in the future. Or inspected in the future, make sure that it's right. So server rollbacks or looking at the desired state of server configuration later. You'll have a concrete ISO that you can go and deploy somewhere and go off and look at. It also enables unattended installation, which allows for automated provisioning, right? So you define what your server needs to look like. It creates the installation media, and then it'll go off and actually do it for you. So let's get to it. I'm going to do a demo. I'm going to show you guys basically how this might fit into your development cycle. And it's best to just go ahead and show that. So let's make an app. And let's start with a build file. This should look pretty familiar to you guys, I hope. Build script. So we're going to make a Ratpack app. We're going to make a small microservice just to get started with. Show of hands, how many web developers here? Like actually write web services? Cool. Show of hands, who knows about Ratpack? Okay, for the rest of you guys, you need to go check it out, ratpack.io. Ratpack is a web framework. It's an asynchronous web framework that's built on top of Jetty. It's really good stuff. In full disclosure, I'm the least active member of the core team. And like I said, I like my own stuff, so. I said Netty, didn't I? Oh, I'm hoping I said Netty. Okay. So basically, what we're doing here is just building a very simple structure of what a Ratpack app looks like, and we'll go off and actually create the app now, and I will show that to you guys. We'll just do a simple hello world example. How about that? Because this isn't a Ratpack talk. Gradle run. So this will get us an application up quickly. So we have something running on localhost 5050. If we go to it, we see we get hello world, right? It's pretty straightforward stuff. Pretty cool stuff too. So what we want to do with this now, so this is the typical workflow, right? You develop the code, you build the code, and then you package it, and then you get it to a server somehow, right? So one of the things that we've done at Netflix as an organization is kind of pioneered this field of immutable infrastructure that we'll talk about in somewhat better depth in a little bit. But the basic idea there is that every build of a piece of software gets a new server, right? And that server has to be configured in a common kind of way. And in the case of the provisioning plugin, you're able to define what that configuration looks like in your script, and then it'll actually go off and build the server for you. What we'll do, so basically, once we have this thing built, we need to then get it into a package that the operating system is able to figure out. And to do that, we can make use of Nebula, which is Netflix's Gradle wrapper library. Where's Justin? Not here. Justin Ryan works on my team, and he and Rob, whose last name I can't pronounce, built Nebula. And it's pretty cool. If you don't know about that, you should check that out too. So we'll put Nebula into the class path, and Nebula has this OS package plugin that we're going to use to basically to build an RPM. And to make use of that, we'll just include it. And then we need to tell it what we want our RPM to look like. And doing that is pretty straightforward with Nebula. So it has this OS package block, and we can say it's a 1.0 release, and we're going to go to Linux, and we're going to copy this stuff from build libs, and we're going to copy that into, we want that to go into /ops/apps, And we want to include, so we're going to build a fat jar here so that it's runnable on the server. We're going to include just the fat jar. And then we need to tell it that when we build the RPM, we have to tell it the name. So we have a package name. We'll call it my web app. And we'll tell it the architecture is no architecture, and the OS is Linux. And this is what will be the secret sauce. So then when we do oh, sure. Is that better? Yeah. Okay. So we'll do we'll build the fat jar, and then we will also build the RPM, and we'll see what that comes out like. Takes about 25 seconds. Cool. 16 seconds. Time got better. So we go, Nebula will put the RPM into the distributions directory. So now we have an RPM in here. And if we look at what that RPM looks like, we can do a QPL. And we can see we have our fat jar that's packed into the /ops/apps directory. And if we have a common location for deploying these RPMs, like Artifactory or bin tray or something like that, then inside of our application, I will actually take you guys to one that's already built for time reasons. Yeah. Whoops. Inside of our application, sorry. Well, we will just jump straight to the example then. So basically, once we have this built, we will be able to define some configuration. That configuration is outlined on the project's GitHub page, which is in /developer/provisioning Gradle plugin. This is where the source lives. This is where the documentation lives, et cetera. And basically, inside of the DSL, like I said earlier, or I'm sorry, the plugin provides a DSL for your build script that you're able to define all the aspects of how you want your server infrastructure to look. And for doing that, so basically we define an installation image. This is the net install image so that we can perform the unintended install. We give it a root password. We can configure networks. Right down to partitioning, so we tell it what the partitioning should look like, and then we tell it what the packages should look like. And the packages are the OS packages, right? And they're the concept of groups in CentOS, for example. So I'm demonstrating CentOS stuff, but this is certainly capable of working with other Linux variants like Ubuntu or something else, even though that implementation is not done. So we'll install some of these groups so that we know that we have certain things. We'll install packages, and one of the things that we're going to do is we're going to install the package for our application, right? And so part of that means that we build the RPM, we publish it, and then including it as a package inside of this packages block of the DSL, we'll tell it to go ahead and install it. And when we run the provision command, which the plugin exposes, it'll actually go off and do that stuff. Now in this example, what I'm going to show you guys is provisioning to VirtualBox, but it's not strictly necessary, right? VirtualBox is one of the deployment endpoints that this is capable of servicing. It's also capable right now of going to Amazon, but I guess the possibilities are kind of endless, because what we're doing is we're building that kind of base server type stuff, and we're pre-configuring it. So any place where we're able to install server infrastructure, we're able to automate that part of the process. So if we run provision, so now we have, basically at this point, what our workflow is going to be is we're going to produce the fat jar, we're going to build it into an RPM, then we're going to publish that RPM, and then we want to provision the server. If we look at what that looks like, you get this. I've pre-recorded this because the network here sucks. On the conference Wi-Fi, I should say. So we're building the fat jar right now. We published the RPM and then repacked the repo. And then provisioning, it went off and did a virtual box provisioning because we have the virtual box aspect configured in the as part of the build script. And I'll show you what that looks like. But essentially what you can see here is this fired up a VM, and it's attached to the ISO that we've built as part of the project, and it's going through the unattended installation of it. So we'll fast forward a little bit, because I think we're getting low on time. How many people here have ever set up a server? Yeah, so you guys know what this looks like. That's basically all of the room. We can see, we get through, and it starts to install the packages, and this whole process takes about 5 minutes, so it's not a big deal. But the point that I'm illustrating here is that this is a totally unattended thing. There's no user input required because we've pre-configured. We've told it what it needs to look like. And it'll go off and do all these things. And we can see towards the end, what we have here is it's actually installing our application that we've built and packaged, right? Because we've told it how to do that. And the plugin has packaged the ISO in a way that it knows where to get all these packages and stuff. So if we play that out, what we can see is when it starts up, it's starting up. And so come in, and if we just take a look at what the IP address is, so I'm just running an if config there, getting the IP address, and then we can come into a browser, type in the IP address, get the IP address, go to the port that it's on, 5050 by default with Ratpack, and we have hello world, right? And so now that's running totally inside of its own VM, fully provisioned, and even better, there's an ISO that corresponds to this. So we can take that ISO, today, right now, running right now inside of a VM, that's perfect for right now. But if we want to, say, ship it off to Amazon or another cloud provider or something like that, we have the ISO, we're able to do that, right? So that's kind of, I think, the important part to understand about this whole thing. So let's get back to it. I think we have just a few minutes, so I'm kind of going to race through this. So a big question that I get is, what is the difference between the provisioning plugin and Chef or Puppet or Ansible or basically whatever your configuration manager of the day is? And the answer that I have for that is this: when you build the installation media in a way that it knows how to pre-configure the server at installation time, you don't need to worry about after-the-fact configuration, right? So you're truly building immutable infrastructure in that case, as opposed to with Chef and Puppet and other ones. They operate in a state where the server has already been provisioned, right? These are just configuration management things. So we're not talking about doing things after the fact. When the server comes up, it's done. There's no configuration that needs to happen. It's fully constituted. There is no concept of a base image, right? Because we're building the server. So it's not being built on anything. We're producing the installation media for it. And another one of the benefits is that we can, because we have that kind of control at this point, because we produce the installation media, we can deploy this anywhere that we want, like I said before. And that includes areas that are security controlled, right? So some of you may work in organizations where you have an operations team or a security team that is responsible for handling your server provisioning. What this will do is this will allow you to give them an ISO and say, please install this. Probably work with them too to make sure they're happy with it. But the point is that what worked on your local machine for testing and configuration and all that stuff, you're giving them that image to go off and install. And again, this is that whole idea of immutable infrastructure, right? We're building a VM or, I said or a container, even though I haven't talked too much about Docker. But we're building a VM or container for every application. It gets rebuilt every time the application gets deployed. You integrate it with your code base, so you know specifically what your server infrastructure is going to look like as it corresponds to where your code is going to run and how your code looks. The startup environment is built, like I said, and everything's ready for out of the box. And this gives you that level of consistency that you really need when you're building apps that are going to go to servers, right? The purpose for this whole thing is because things are changing a lot. Like I said, I'm a Red Hat certified engineer. I have a background in system administration. I'm haphazardly a programmer, not as a result of that. But I think the idea here is that we're kind of changing the landscape of server architecture and system administration. And as a result of that, we can't stick to that old way of thinking where we have a server running hot and then we're going to install software onto it, right? Like these things need to be built every time that we do it, and they need to be change controlled, version controlled and change managed in a way that corresponds to the code that we're running on that server. So this idea of immutable infrastructure is a pretty important one, and I feel like it's what has allowed Netflix, for example, to grow at the rate that it has. So some more details on the provisioning plugin just itself. Like I said before, it has that configuration DSL that you can bake right into your build script. So you get it allows you to configure the installation media, configure authentication, disk partitioning, basically everything that you need to do, including pre and post installation stuff. So you can write bash scripts directly into it. And those effectively get put into a kickstart file that gets run when the server gets provisioned. Provisioning support, so where I want to go with this is right now we can go to VirtualBox. That's fairly easy. They actually have a really good just API for doing this stuff. They provide good Java bindings, so that makes a lot of sense for Gradle. There's also some AWS support in there. In the future, where I want to go is to containers with this. That's the most important thing that exists in the world. There are already a lot of, if you guys were at Ben Mushko's talks yesterday, you probably saw it, the Vagrant and Docker stuff he was talking about. There's already some good Docker plugins for Gradle, so I'm not exactly sure where we're going to overlap there, but certainly the idea of getting your code into something, whether it be a VM or a container, and then shipping that something to the cloud is extremely appealing, and that's an area that I want to tackle, and is totally pertinent for the work I do. Known limitations of the plugin. The AWS integration just flat out sucks right now. It needs to get a lot better, and I want it to get a lot better. Basically, it'll only produce HVMs for you, which if you're okay with that, then that's great. It'll work perfectly for you. I know how to get it to do PVs. I just haven't had the time to do it, so that's definitely next thing on the roadmap. It also relies right now on an external Yum repo being consistent, and I really hate that idea. It's okay as a stopgap measure, but the point that I want to get this to is the installation media will actually have your RPM baked into it. That is another thing that I know how to do, but just haven't gotten to it. So that'll be probably after the AWS integration. It only works with CentOS. I'm, Red Hat engineer before. I'm very comfortable in that space, so it was pretty easy to get up and going with it. But Ubuntu is obviously very popular, and it's also capable of unattended kickstart and installations. I know that much. So Ubuntu integration at a minimum will be important. It's also pretty difficult to test. So every time that I make a change, I have to go back through a provisioning, and that can take 5 minutes each run. I'm hoping that the improvements that are coming with Gradle 2.0 will give me a little bit more confidence over the testing of the actual plugin, so that I don't have to do that every time. And the deployment architecture right now, I didn't do a great job implementing VirtualBox and Docker as targets. I actually kind of came to that as a second thought after the fact. So I want that now. I'm pretty happy with it though. So I want it now to be pluggable so that we can support basically any kind of destination or endpoint. And again, it's open source. If this is something that interests you guys, please send me pull requests or raise issues or whatever. It doesn't get nearly as much attention as it should, and I'd love to have other eyes working on it. Last but certainly not least, like I said before, I work at Netflix. We do delivery engineering. We do build engineering. We use Gradle heavily, and we're hiring all the time. So if you guys are exceptional folks, contact me, reach out to me, go to the jobs.netflix.com and send your resume, and let's get that process started. Let's get you on board. Questions? You mean for a target, yeah? Yeah, I do. Oh, sorry, yeah. The question was, do I see this always being a Linux solution? I do. Other questions? Comments, concerns, snide remarks? Yeah. Snide remark. I don't disagree with that. This isn't designed to do that. But what I would do is challenge the reason why you need a long-lived VM. Sorry, the question. The question was, this is not comparable to Puppet. This is not comparable to configuration management of servers and pushing that out to many servers at once. That's the question, right? To long-lived VMs. Yeah, and my answer to that is that's true. But again, I would challenge the assessment of why do I need a long-lived VM? If you have a need for long-lived VMs, something that is, that you're not going to be pushing rolling updates to or updating very frequently, something like that, this is not the answer for that. It can get you started, it can bootstrap you, but something I probably didn't articulate well enough is that this is not in direct competition with things like Chef and Puppet. These are very different use cases. But for the purpose of, like, I need to deploy my application to a web server, I wouldn't reuse the same VM twice. And basically for that, the need for Chef or Puppet goes away because you can configure it at installation time. Yeah?
Is there support now?
So the question was, is there support for interactive installation? And what was the reason again?
Yeah, we come configuring clustering servers.
For clustering servers and configuring servers. There's no support for that. I'm not sure I fully understand what the use case is, but I think it's another scenario where, like if you're joining it for the purposes of like a shared file system or something, is that why you cluster? Or
We add some software to like very.
I don't know. I think one of the whole purposes is for automation, right? I don't know how it fits into something that would require interaction. Exactly. All right. Thanks a lot, folks. Appreciate it.